Okay, they gave us the graph of f with selected values of g, also in a table, and the graph of g prime is continuous on the interval from -2 to 2. Good to know. Use the graph in the table to evaluate each of these definite integrals. Before we get any further, let me write down some stuff that you just learned. Dx equals capital F of B minus capital F of A. And we're not going to worry about uppercase, lowercase, all that stuff. What I am going to deal with, excuse me, is that this and this are if I could spell, derivatives. Okay, so again, don't worry about uppercase F and lowercase f and all this and uppercase G and lowercase g. I just need an antiderivative of whatever's in here. Well, what's in here? The derivative. What's the antiderivative of a derivative? Well, in this case, it's just f, okay? You're undoing this prime. This is f prime, it's the derivative. The antiderivative of a derivative, wordy as it sounds, is simply just f. F of x, evaluated from -1 to 2. This is a different representation from that, but it's the same idea because we're about to say f of 2 minus f of -1, which is going to give me, let's see, f of 2 is 6. F of -1 is -3. So 6, make sure I'm getting this right. My scale here is on a scale of a half, so I've messed up on this in the past. It's the second time I've made this video, full disclosure. There you go. All right. This next one, we want g prime, integral of g prime, the integral, an antiderivative, integral, antiderivative, same thing. The integral of g prime is just g. So we're going to evaluate g from 0 to 2. So we need g of 2 minus g of 0 with an ink pen that's running out of ink, but we'll go with it. G of 2, let's see, g of 2 is 6. G of 0 is -3. And that gives me 9. So far, the answers are 9. So when in doubt, just put 9. That's going to be it right there. So let's move on. The next one. Oh my goodness. We're going to have to apply some of the rules of, or some of the properties of integrals. Like, for example, if I'm subtracting, I'll just subtract another integral. Let's just go ahead and start there. From 1 to -2, g prime of x dx. There's that one. And then this first one, I'm going to put that one. So 1 to -2. We'll just put a 5 in the front. Another one of those properties. We'll put the 5 in the front of this one, f prime of x dx. So here's what's about to happen. We're going to find out what happens with 5 f of x, that's the antiderivative of that, from 1 to -2, minus g of x from 1 to -2. Now, if you're looking at this, thinking back the way we've done things in the past, you probably thought, these numbers are backwards, so we can turn it around and change the sign. You can, but you don't have to. I didn't, but you can if you want to. So we have 5 with f evaluated at -2 minus f of 1. We'll figure that out in a minute. And then g of -2 minus g of 1. This ink pen's about to go. Can we finish the problem with this ink pen? I don't know. 5 f of -2 is 2. Good for us. Minus f of 1. F of 1 is 5. Okay, minus. All right, g of -2 comes from the table. There it is, -3. And g of 1 is 5. All right, that's what we have. So 5 times -3 minus -8. That's going to give me -15 plus 8, which is -7, and we have a little bit of ink left. There we go.